All right, so we talk. Let me just go ahead and giving you a quick review, very quick on how to get to the D2L very quick. If you go to Dallas College homepage, look at the online tour, and then just click eCampus, it will take you to here. Okay, so after you log in, you can click this one, or you can click this one to look at all the courses you have. All right, so you go to the you cost look at your cost name. If you click the content, it will list everything in here. So go to the MindLab Math. All right, if you go to the MindLab Math, and you can just click the course homepage, or you can just click the assignment. Either way, it will take you to there. Okay, so if you go to the home page right here, let me view students home. So if you click the current one, it only show a few. I like to click the entire course today, so it will show everything in here. Okay, and that is the homework 1.1, 1.2. The video, since we are lecture, so video is optional. For the online 100% online course, video will be required. Okay, so I leave the video here, so you can, this is a Pearson video, so you can review on your own. We also have a course video in here, and since this is a prerequisite course, so we have I move this prerequisite to the a little bit down here. Okay, so you have a little bit of skill review quiz and the homework. It's not a lot, but just a few questions that we think you're gonna be benefit to our course. All right, so this one we hope to complete all this review by October the 1st, so that way we can get over those skill review, and then we can just concentrate on the statistic that way. Okay, all right, if we need a little bit review, we can always pull a little bit more, but right now it's just a little bit only. Okay, all right, so we finished 1.1 last time. We're gonna have a 1.2, 3, and 4 today. Okay, so the second section is just distinguish the about the observation and the experiment. Okay, distinguish what is observational study and what is experiment, that kind of thing. So basically, observation study is you just watch, you don't do anything different. Okay, so that's the observation in here. All right, so look at this example. Research want to determine whether there's an association between mobile phone use and brain tumor. Okay, so to do so, they include this many women in UK, and follow a period of 7 years. Okay, and then there were 1,261 instances from the of the brain tumor. Okay, out from the 791,710 middle-aged women. All right, and the research compared the women who never use a mobile phone to those who use a mobile phone, and found there's no significant difference in the incident rate of the brain tumor in these two people. So basically, they don't do anything different. They just observe, or they just watch, right? So apparently, this is called a observational study, because they don't really give anyone anything special. All right. So that is the observation, and sometimes in the research we also call some of them called exponential variable. Okay, and then this exponential variable, usually in math we kind of like to say x-axis, right? And then we have a response variable. So response variable usually is on the vertical one called y-axis. Okay, so we usually, instead of using x and y, we using the exponential variable. Sometimes it's also called independent variable. Okay, and then response variable, sometimes we also call it is a dependent variable. All right, so it's just a little bit different name in here, which you kind of want to get to know a little bit. All right, So what is the observational study? Is measure the values of the response variable without attempting to influence the value of either the response or explanatory variable. So basically, you don't do anything different. You just watch. Okay, just watch. That is the observational. If a researcher assigned individuals in a study to a group, intentionally manipulate the value of an explanatory variable, then record the value of the responder variable for each individual, this is called conducting a design experiment. Okay, so what is an experiment? That means you do something different, right? Just like in agriculture, you apply some fertilizer to one piece of the crop. Another piece of the crop did not use the fertilizer. And then you try to compare what is the outcome for these two. So those are called experiment. We trying to see if the experiment, the fertilizer work or not. Okay, same thing is in FDA trying to approve the drug. They also do the experiment, right? So they conduct a study, give this group of the patient medicine and did not give the other group of the patient medicine, and then they're trying to compare if the medicine work or not. Okay, so those are called the design experiment study. All right. There's a little bit of, in statistics, we don't really test these two variables, but it's nice to know. So what is a confounding variable? What is a locking variable? Okay. The confounding variable in a study occurs when the effects of two or more explanatory variables are not separate. Okay, so any relation that might exist between the explanatory variable and the response variable may be due to some other variables not accounted for the study. All right. So sometimes I want to give you a very classic example for this called confounding variable. All right. Usually, sometimes people say, when the ice cream sales going up, crime rate also going up. All right, so some people say, well, what's the relationship between the ice cream sale and the crime rate? Okay, actually, there's called confounding variables in here because the ice cream sales going up usually is in the summer, okay, hot weather in the summer. And in the summer, more people are going out and, in the park, going to the park, going to travel or whatever. And then leaving the house empty, right? Or you people going outside in a public place, you also more chance to suffer from robbery, all those kind of things. Your house got break in, or all those kind of things. So actually, it's weather. Weather is called a confounding variable here. Okay, so weather is kind of the third variable in here. So when the ice cream sales goes up, usually it's in the summer. All right, so those kind of variable is called a confounding variable. Okay, it affected by some other third variable factors in here. Okay, a locking variable is an explanatory variable that was not considered in a study but affect the value of the responder variable in a study. Okay, so in addition, locking variable are typically related to any explanatory variable considered in a study. So those just kind of, sometimes in statistics people talking about. All right, like I said, we don't really test a little bit about it, but it's nice to know. Okay, some of the locking variable in the influenza study say, age, health, morbidity of the senior, right? So like I said, COVID-19, if people got a virus, some people die, some people can survive. So even they both giving the COVID shot, okay? So, COVID shot is the same, right? So everyone get a COVID shot, for example. And then some people still got sick, some people don't. So because maybe some people are healthier than the others, some people maybe just get older. So age, health status, those kind of called a looking variable in here. All right. So it will affect the outcome, that kind of thing. All right. Okay, so observational study do not allow research to claim the causation. It's only the association. Okay, so we have to know what is the association, what is the causation. So for example, sometimes the people say smoking and lung cancer. Well, smoking doesn't really cause the lung cancer, so that's not a causation, but it's highly associated or related to the lung cancer. If people constantly smoke one pack of cigarette every day, the chance of developing lung cancer will increase. Okay, so that's called association. So not a causation, but association. Causation, that means if you don't smoke, you won't develop lung cancer, because if you say that the smoking causes the lung cancer. All right, but that is not true, right? People do not smoke, sometimes still get a lung cancer. So that's called it's an association, not a causation. Okay, so those kind of tricky thing in statistics, we kind of want to know that way. All right. So that is pretty much for the section 1.2. It's just a little bit in-depth study for all these variable. And another one is called a confounding variable. Okay, so confounding variable is an explanatory variable that was considered in the study, and the effect cannot be distinguished from a second explanatory variable in the study. Okay, so those are the confounding variable as we talked earlier. All right. So that is the type of the observation study. That one I will let you just do your textbook on your own. We are not going to explain too much about that. Okay, those are getting a little bit more detail, but we don't really use a lot in here. One thing I want to point out is the census. Census is the government do that in every 10 years. Okay, so if you go to the census.gov, you will find all kinds of information. This is the only surveys the government do using the population. Okay, instead of using sample, you're using the population. That means they're trying to survey everyone, and it's very expensive, take a very long for the data to pop up. Okay, usually take 6 months after the census survey for the data to pop up. All right, so those are using the population. All right. Okay, we want to have a more important here is the sampling technique in 1.3, which is 1.3 is more important than 1.2 for sure. Okay, because we need to learn how to do the sampling in order to do the good survey in here. So obtain a simple random sample. So what is a simple random sample? Okay, simple random sample, or just called a random sample, is a process of using chance to select individual from a population to be included in a sample. So random sample, that means that everyone has an equal chance. Okay, everyone has an equal chance of being selected. That is a random sample. Okay, a chameleon is not a random. Chameleon is not a good one. Okay, chameleon sampling technique is not a good one. All right, so how do you obtain a simple random sample? Well, you can put a number on everyone and just pick from the number, or you can pick a name in a basket, right? And you just randomly draw one, or you can download like the student ID, and then anyone has any questions? Do you have any questions? All right. If you have any question, you can just unmute yourself and talk about it. Okay, you can ask the question. You can unmute yourself if you have any question right away. All right. So the random sample usually is also called a simple random sample. You can use the statistical software in Excel or other statistical software, or even the TI-83, 84 calculator. They can generate a random simple number as well. Okay, you can just randomly choose one. You can randomly choose 3 at a time, things like that, that kind of thing. All right, and then you can random sample with replacement, one random sample without a replacement. So what does a random sample with replacement mean? Like I said, if you have a 10 number, and then you randomly pick one, okay, and then you put that one back to the basket again, so that is with the replacement. You select one, okay, after you select one, you put that one back, so that's the replacement. Without a replacement, that means if you from 1 to 10, right, and then you pick a 5, so 5 is picked, and then you don't put a 5 back, you just put a 5 on the side, so that's called without a replacement. Okay, and it will affect the probability of you choosing the second one. So just have to read the question very carefully. If it's select with replacement or without a replacement, it will be different. Okay, so later on when you do the calculation, you just have to be careful with that. All right. Okay, so let's go to the next different technique here. Look at that. This one you can go. You can. This is showing you how to generate the random sample from the TI-8384, right? So you can input this random integer non-repeat. Okay, non-repeat. So you from 1 to 30, you want to pick 5 numbers. So that is how the syntax read. Random integer non-repeat, okay, and then you choose from 1 to 30, and then you want to pick 5, and then this is the outcome. All right, so that you have 11, 4, 20, 29, and 7, so that is your random number. All right, so that's how you pick the random number in the calculator, or you can put it in the Excel as well. All right, so basically that is our section 1.2 1.3 actually. All right, so the first chapter basically do not have any calculation, at least so far we don't see the calculation. Okay, we're gonna continue on this one right here is 1.4 sampling method. We only talked the simple random sample earlier, but now we're gonna talk the stratify and the systematic and then the cluster sampling technique. Okay, so those are the a little bit more in-depth technique than just a simple random sample. So how do you attain a stratify? Well, sampling technique is good, right? Everyone has an equal chance of being selected. But for example, if I want to select 4 people to go to a conference, and if I want 2 male, 2 female, if I use the random sample, it's not going to guarantee I will have 2 male, 2 female. Using the simple random sample, I might get 3 female, 1 male, or the other way around. Or I might have all 4 people are male, or all 4 people are female. Everything is possible, right? So if I want to guarantee 2 male, 2 female, so what do? I will need to use the stratify. Okay, so how stratify work? This stratify is by separating the population into non-overlapping group called strata first, and then you're using the simple random sample for each one. So basically, if I want to choose 2 male, 2 female, I will separate the group into male group and female group first before I do the simple random method. Okay, so that's the difference, the beginning from beginning. So stratify still using the simple random method, but the difference here is I separate into group first, separate into male and female first, and then I go to male group randomly choose 2. I go to female group randomly choose 2. So that is called stratify. Okay, and we use a lot in stratify in here. All right, So stratify use like say when I do the class survey, right? I want to evening class also got a survey, weekend class also got a survey, of course day class also got a survey, online class also got a survey. So how do I do the stratify? If I use the simple random method, maybe I will choose all just daytime class. And those evening, online, weekend class won't get a survey, right? So I will using a stratify to see how many percent are online, how many percent are evening, how many percent are weekend class, and I will divide the survey into those percentage, okay? And that is called a stratify, okay? So stratify, you cannot make sure everything is proportion that way, all right? So stratify is a good survey sample in here. And then another one is called a systematic, okay? So what is a systematic, which is very easy, is systematically select every case individual from the population, right? So for example, if you go to the airport and they randomly choose the number 10 to have an additional check, right? So you're gonna have a number 10, they got an additional check, number 20th, 30th, 40th, 50th, 70, 60, something like that, right? You systematically choose people for the additional screening. So that is the systematic, all right? It's pretty easy in here, okay? All right, you can have every 10 or every 20 or every 100. It really doesn't matter, all right? So those are the systematic in here. Another one is also very important. It's called a cluster sample. Cluster, sometimes people confuse it with stratify, okay? So what is a cluster? This is attained by selecting all individual within a random select collection or group of individuals. All right. So cluster, let me give you an example for the cluster. All right. So cluster is kind of like I have all these big pie, right? And I am going to separate into 4 pieces. All right. So they separate into 1, 2, 3, and 4. All right. So a little bit similar to the stratify at the beginning, you separate into different pieces or different group. Okay. All right. After you separate that, the difference of the class, the stratify is going to randomly pick 1, pick 2 from each group. Okay, that's a stratify. Cluster is not. Cluster, that means, okay, I separate into 4 pieces. And then if I just randomly pick one, if I pick this piece, that means I'm not going to pick randomly from this piece. It's entire this piece gonna participate. Okay, so it attained by selecting all individual with this random select piece. Okay, if I randomly, like I say, if I randomly choose a class, right? Everyone in our class will participate. So that is a little bit cluster in here. All right. So if our class got choose, we are not going to the class to choose 1, 2, or 3 students, but instead entire class is gonna participate in the survey. So that is called a cluster. Cluster is the whole thing, the whole piece. All right. So they also separate into pieces first, and then randomly choose the whole piece, the whole pie, basically. Whole quarter of the pie will participate. All right. So that is called a cluster in here. Okay. All right. Another survey sample here is called chameleon. So chameleon is the individual in the sample is easy to attain. All right. Chameleon sampling technique is not a good one. Okay, because it's just chameleon to the people, but not a scientific one. So think of the chameleon sampling technique. If someone say, hey, I only work from 8 to 5, okay, like the border control or U.S. custom, right? They say, okay, I'm gonna just work from 8 to 5. I'm not going to inspect any wood come to U.S. after 5 o'clock. So the drug dealer, they might be able to, smuggling the drug, at night, that kind of thing to US, right? So you cannot just say, I'm gonna just random sample, I'm gonna just choose the convenient time or convenient sampling like from 8 to 5, okay? So we have to be very careful with the convenient sample in here, all right? Okay, so look at this one right here. Okay, if you look at this picture, what is the simple random sample? Simple random sample, if you go to the group in here, right? Go to this population, and you just randomly choose 1, choose 2. This randomly number 2 got randomly select, number 9 got randomly select, number 5 got randomly select. So that's the simple random sample, all right? And then if you look at the systematic, it's also very easy. Look at that. So this one got number 2, and then every 3 you got picked. So this is number 5, and then you add the 3 number will be number 8, right? Add another 3 number will be number 11. So every third person got selected in here, all right? So those two should be really easy. Now look at a little bit not so easy. Here is the stratify, okay? So this is the population, and then according to stratify, they separate into 2 groups, right? Group 1, group 2. And then you go to the group 2 to randomly, group 1 randomly pick 2, all right? And then this go to group 2 randomly pick 2. So that's the stratify, okay? All right, so what is the cluster in here? All right, cluster is, this is the entire population, right? So the entire population, but this entire population, I put it into several blocks. So 1, 2, 3, 4, 5, 6. So I put these 24 people into 6 block in here. And then I just go to randomly pick 1 block. So if I randomly pick this block, everyone in this block is gonna participate. Look at it. So I just randomly pick 1 block and then randomly pick another block. So if I pick 1 block, that means everyone in that block is gonna participate. Okay? So this is giving you a little visualize in a sampling technique in here. Hopefully they help. All right. Any questions about a sampling technique?
No questions.
All right. Okay. One thing is about a statistic. I will a little bit different than the pure math, right? So I will suggest that everyone read the textbook at least once, okay? Because sometimes the PowerPoint did not giving you the whole story, that kind of thing, and we don't really want to read the entire textbook as well, in a class, okay? You can read the textbook on your own. So we just want to point out the key concept, the important concept here, and the formula as well, all right? So if you're trying to connect all the story together, reading the textbook at least once, right? Every time when I teach a new class, I always read the textbook or at least once, or update to the new version, okay? All right, the last section for the chapter 1 here is bias in sampling, okay? So this is kind of actually it's very important, right? So what do you include in a study, right? So sometimes people say, well, all this medicine doesn't work for a minority group of people because when they do the study, they only choose, like a majority of the group, things like that. So that is kind of create bias in sampling, okay? So, after you learn the statistic, you kind of will learn a little bit more how to choose the good sample that way, okay? Describe the characteristic of an experiment, that kind of thing, okay? So there's in the experiments we have a variable or called factors, okay? We create like a influence the response, right, or the treatment in here. And there's called control group or called a placebo group. Control group usually is used as baseline treatment that can be used to compare to other treatment. Okay, so usually you have a control group in here, and then the placebo. All right, placebo usually is sometimes called sugar pills. Okay, so placebo usually when people in the placebo group, that means they do not take the medicine, but they're still taking something. They give them a sugar pill, basically. But those people, they do not know, okay? They do not know that they are in a placebo group. So sometimes even people in a placebo group, they think they are taking medicine, and because they do not know. That's called a brain study. They do not know they are not taking medicine, but they do take something. So, in a study before, some people, even in a placebo group, say, hey, I do feel better, okay? So that maybe psychologically they feel better, or they may just, they feel better not because of the medicine, but because of some other thing, okay? So that's the placebo in there. So usually they have a control group and a placebo, so they're trying to compare the two different outcomes that way, all right? There's called a brain study. Brain study, they have a single brain or double brain. The single brain, that means the people participated do not know, but the doctor or the surveyors, they know, which group has medicine, which group do not have a medicine. All right, there's one called a double brain study. Double brain study, that means, the distributor and the researcher, or the distributor and the patient and the people in the study both did not know which one is medicine, which one is placebo, okay, sugar pill. So those are called a single brain and a double brain study, that kind of thing in here, all right? So there's also a little bit sampling bias. So what does the sampling bias mean in here? Sampling bias, that means the technique used to obtain an individual to be in a sample tend to favor one group than the other. Okay, so that's a sampling bias. So like I say, some people, they all just want to choose, like I say, the people they favor, right? Whatever the group of people they favor to be included in a study. So those are the sampling bias to begin with, all right? The sampling bias can also result due to under coverage, which occurs when a proportion or one segment of the proportion is lower than in a sample. Sometimes, like I say, for example, Hispanic population, I'm gonna just talking this one as an example, right? So if the Hispanic population is 20% of the population, and they don't use the 20% of the sample in the study, that would be called a sampling bias, right? If they lower than 20%, for example, something like that, right? Not proportion to that. And then there's also called a non-response bias exists when individuals selected to be in a sample who do not respond to the survey has a different opinion from those who do, right? So sometimes, like going to vote, right? A lot of time people do not go to vote because I don't really care. I don't really care who wins. So those are the, non-responder bias. You really want to go to vote, So or sometimes when we send out a survey, right? And then the survey people do not respond because I don't really mind. I'm not really love this one. I don't really hate this one. So I don't really care. So those are called a responder bias. And only two group of the people respond and say, oh, I really love this one. And then some people say, I really hate this one. So you only create two extreme group of people respond, that kind of thing. All right. So those called a non-responder bias. So you really want to encourage those group of people to respond to the survey, right? We usually send out a survey and we want everyone to respond, so we give the incentive to people, that kind of thing, all right, to avoid the non-responder bias. All right, so now there's a responder bias, right? So responder bias, that means, the answer on the survey do not reflect the true feeling of the responder. Okay, some people, that's not good either. All right. So there's several type of the bias in here. You have interview error, you have a misrepresentative wording of the question, all those kind of thing, order of the question or word. If you put your favorite thing in the front, sometimes the people just check the front one, right? And then put an unfavorite thing at the end, and then they say, oh, I don't want people to check the end. Sometimes people do not read the question until the end, that kind of thing. Okay, type of the question, open or close. All right, so the way you ask question can also influence the people's response as well. Okay, so and then of course the last thing here is that you got everything right, but you have a data entry mistake. That's not good either. All right, so in order to get a good survey, there's a lot of work in between. All right. Okay, so that is the first one in here, the design of the experiment. So this one we don't really cover that much in here. So basically the sampling technique is the most important one for this section. All right, the rest we don't really cover that much. So that is just giving you a little bit overview, basically giving you a little bit overview of what is a statistic, okay, and how do you do the correct sampling, so the sampling technique, do the simple random, what is a simple random, what is a stratified, cluster, and systematic, okay. So those are the good sampling technique we want in this section, in this chapter actually. All right, so the chapter 1, you don't do any calculation at all, just a little bit introduction about the statistic. When you got to chapter 2, now you're gonna start having a calculation, okay? And then when we do the calculation, we also need a calculator. All right, so we are showing you a little bit more how to use a calculator in the chapter, okay? And then maybe do a little bit graphing. So the 2.1 here is organizing the data and then do a little bit graph, okay? We don't really, most of the graph, you can do that in a calculator or in a TI 83, 84, or even Excel. All right, so we don't really ask you to construct the graphing by hand. Very few, basically, okay? So you can, but you need to be able to read a graph. All right, so when we're giving you a graph, you need to be able to do it and answer the question. So basically that is the most important one in here. All right, so in chapter 2 here is organizing the data and summarizing the data, right? We talk statistic is about collecting data, organizing data, and then summarizing the data, and then you analyze that, and then you want to be able to do the conclusion. So that is a statistic. All right, so the first chapter we all talking about how to obtain a sample, right? So after you obtain a sample, you need to collect the data, okay? So you input the data into the system, but now you input all those data called raw data. You need to be able to organize and summarize to get a useful information, right? So we want to organize the data in tables, okay, into table, and then construct maybe some bar graph or line graph or pie graph or whatever graph you feel like, okay? So as I mentioned that earlier, what is a raw data? The data is correct from a survey or design experiment, right? They must be organized into the manageable form. The data is not organized, it's called the raw data. So that means you first-hand data, right? And then you don't want to lose the first-hand data. So those are the raw data in here. Okay, so you got a bunch of the raw data, maybe 100, maybe 10,000, like the data I handle in at work, maybe a few thousand, at least a few 100,000 at once, or sometimes maybe 100,000. All right, so how do you organize those into table? All right, the very basic one here is called a frequency distribution. All right, so the frequency distribution here is list each category of the data and the number of the occurrence for each category. So like I said, if I have 100 students in my class, okay, in all my class in here, and I want to see how many students, so I have 100 students, I'm going to have 100 course grade, right? And I want to count how many people got A, how many people got B, how many people got C, and so on. So those are called the frequency distribution. So how do I do that? Okay, I can do that by hand, which is gonna take a long time, or I can put it in a calculator or put it in an Excel and then do the frequency distribution. So either way will work. Okay, look at this one right here. Look at this is the physical therapy. Okay, this is a physical therapy. People suffer from pain, right? So you have a back pain, you have an elbow, you have a hip, you have a neck, you have a shoulder pain, you have a knee, all those kind of things, all right? So maybe you just recall these people. This is a sample of 30 people, okay? 30 patients going through the physical therapy. And some people going physical therapy because of the back pain or because of knee pain or hand pain or whatever, or shoulder pain. So this 30 information doesn't really give you much information, right? So we want to organize this into a table to how many back pain in here, how many elbow pain, how many neck pain in here. So what do? Well, you can use one called tally, okay? So what's tally mean in here, all right? So I can, the tally here will be I put a table, right? So I put a table in here, okay? So I put a table, like I said, I have a back pain, okay? And then I do this one right here. So the first one, I get a tally. I have a first one is a back pain, and the second one I also get a back pain, and then the third one I have a hand right here. So I put a hand right here. It's hard to do it in here, so I'm gonna just using H for hand. All right. So I have a hand right here. So I made a tally. This one right here. All right, so I finished the first row, right? And I'm going through the same thing with the second row. And in second row, I have another back pain right here. So I add one more bar in here. So that is called using this one in here. You can go through for every line, and then this is called a tally, right? And after you get this tally in here, and then you count how many you hear. So this one you got 5, so plus 2, so you got 12. All right, and then the risk, you only have 2 elbow, you got 1. So basically you count them manually. All right, and after this frequency in here, you can add up these 30 frequencies to see the total if it's 30 or not. If it's not equal to 30, then maybe you mix something in here, right? So this is manually count. Some people ask me, how do I count them? I say you count them manually. All right, whatever way you want to count. If you just want to go through, count all the back, like 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12. Okay, so you have a 12 back. So if you want to count that way, that's fun as well. All right, but that way you have to go through the table several times, and then you count the hands. So there's one hand right here, right? And then you go through everyone right here. So where else you have a hand? Or another hand right here, and that's it. So you got 2 hands. So that's another way to count. If you want to go through the whole table, several times, that's another way. And then wrist here. So how many wrists? That's 1. Okay, and then you go to look at this one right here. Oh, there's another one right here. So you got 2 wrists in here. All right, so that's another way to count. Okay, and the easy way is going through the tally. You write down whatever the new one, and then just go through table once, and then write down everyone. So that's one way to count. Okay. All right, after you counted the frequency, we can do the calculation. So this is the first formula you have in the calculation, right? So what does 12 mean? Okay, I have a 12 patient coming for the physical therapy for the back. All right, so what does 12 mean? Well, sometimes 12 doesn't tell you the whole story. It's 12 out of 100 or 12 out of 30, okay? So if I change this 12 into percentage, it will make more sense. So the percentage is also called a relative frequency, okay? So the relative frequency is using the frequency divided by the sum of all the frequency. Or sometimes we using the formula in here. The frequency we using F for the frequency. And the sum of all the frequency we using N. So you might see the first formula in the formula C here is called F over N. Okay, F over N is the frequency, relative frequency distribution. All right. So how do you calculate the relative frequency in here? You using 12 divided by the total. Okay, you add all this together, total is 30. And I can show you a little bit doing this one in the Excel, which is really easy. Okay, so or you can do that in a calculator one by one. All right, so but I want to show you Excel a little bit because everyone gonna have an Excel to use. Okay, so in order to do this one, I will have to type this one. Okay, I have a back. Here is 12. Okay, and then I have a wrist. Here is 2. Elbow is 1. Hip is 2. Okay, so shoulder, knee, shoulder is 4, knee is 5. Okay, all right, let me go ahead and save this a little bit just in case I delete something. I'm gonna set first one. Okay, all right, and then hand in here, hand here is 2. All right, arm here is 1, neck here is 1. Okay, and then we have a total in here. Okay, so that is called a body part, and then this is the frequency. All right, and then we're gonna find a relative frequency in here. Okay, so let me make this a little bit bigger. All right, so if I do this one right here, I want to find a total, right? So I can add this one right here and then go to the home page in here. And there's auto sum. Okay, so this is auto sum. When I put an auto sum in here, it will show you my total here is 30. All right, so that means I add all this together and the total is 30. All right, and then the relative frequency here, I can just put an equal sign in here and then just click this cell and then say divided by 30. Okay, and that is my relative frequency in the decimal point, right? And the good thing is using Excel, you can just drag this one, drag this leg all the way down, and everything will be calculated at once. So you don't have to do that one by one. Even in a calculator, you still have to type a one by one in here, everyone divided by 30. But the Excel is very smart, so I using my J3 divided by 1 divided by 30, and then you can see this one, it will follow the pattern by itself, right? So this everyone divided by 30, look at it, okay? So this relative frequency add up together should be equal to 1. Okay, 1 is also 100%. All right, it's exactly equal to 1. Okay, And then if you want a frequency here, yeah, if you want a percentage, you can insert a percentage. Okay, you can insert percentage in here. All right, insert a percentage, and it automatically multiply 100 by itself, and then add a percentage in here. All right, so that's why using the Excel is very easy, very interesting in here. All right, so now instead of using 12, you can say, well, 40% of the people suffer the back pain instead of 12. Okay, so 12 out of 30 is 40%. Okay, so I would rather the 40% giving you the more information than the 12, in my opinion. Okay, so 40%, you can see how many percent is there, right? So that is this one right here. So that's why I like the percentage instead of just the number in here. Okay, any question about it? And this one run to 4 decimal points. So yeah, in Excel, if you want to run to 4 decimal points, that's fine. All right, so I don't want a percentage. I can take the percentage back. I can change this one. I can go to format the cells, or you can just undo, right? If you just undo, it will take you back to the decimal point right here. And then you can increase the decimal point, right? Look at it. You can increase to 4 decimal point. You can increase to this is 4. All right, the book using the 4 decimal point. So you can increase or decrease decimal point in here. All right, so that is the good thing with the Excel. All right, so you can do it pretty much automatically. Any question about how to use Excel? Learning Excel a little bit, even you can use a calculator one by one, but Excel will automate a lot. Okay, and then we're gonna construct a bar graph. So what is a bar graph? Bar graph is, you can do that in the Excel. Okay, so I'm gonna show you the bar graph in here. All right, so let's see, we have this frequency. All right, I can go here, insert a bar graph. So we can insert a graph in here. And this, you can have a vertical bar or you can have a horizontal bar in here. It's really totally up to you. Okay, so I'm gonna just put a vertical bar in here. All right, so this is my bar graph in here. Okay, and I can add a title. I can change the title in here. Ooh. All right, if I miss something, I can undo, right? All right, so I just need to change this title, right? So I'm gonna just say this is body part types, something like that, or you can do whatever you want. All right, and then this one, you can look at it. You can show this a little bit more because it doesn't really show you the label very well. So you can probably increase this one a little bit. Okay, put a number a little bit bigger, and it will show this one right here. You can even change the color for that one if you want to. Okay, you can go to the individual, and then you can change to a different color if you want to. All right, so you can pretty much customize into anything you want. Okay, if you can change the whole color, or you can just change the individual color, that kind of thing. All right. And you can even show the number in here. Okay, so I wanna so this is basically, this is called a bar graph, right? You can add a data label in here. Look at it. Now this one, you have a data label, and then if you want this data label a little bit bigger, so it's a little bit more readable, now you have this data label in here. All right, so now this will be pretty good chart in here. All right. So those are called a bar graph. Okay. You can, if you're trying to do the project, you can add a little bit of this kind of graph on the project. You'll be really good, right? So that is the bar graph. Okay. All right, you can have a vertical one or you can have a horizontal one, whatever bar graph you want in here. There's another one is called a Pareto chart. So what's a Pareto chart? Basically, it's still a bar graph. Okay, they're just using a decreasing order for the frequency. So you put a highest order in here and then a descending order. So if you put a descending order, that become the Pareto chart in here. All right, so how do I do the Pareto chart? Okay, I am going to short this one. Okay, I'm going to the data and I'm going to short this one in a descending order. Oh, that is not in a descending order. Had to be in a F, okay? Not one right here. All right, so now I short this data into a descending order. Now this graph will become a Pareto chart, okay? So the reason it become Pareto chart because I have this in a descending order, all right? In the graph, bar graph in a descending order. So, you know, some people just say, okay, I'm gonna give you a different name, right? So basically it's still the same graph in here, okay? Pareto chart is a bar graph in a descending order. All right, side-by-side bar graph in here. So like I said, you just pretty much need to know how to read the graph, all right? So this one, you have, you know, education attainment compare 1990 to 2017, right? So you have basically you have 2 years of data and then you put it side by side so you can kind of compare them in here. So look at that, blue one is 1990, 2017 is the green one. So if you look at this graph right here, so looks like this year. All right, this year in 2017, or even in this year, associate degree, look at it. 2017, you can see associate degree, people getting associate degree is increasing, right? And then even more people got a bachelor degree, and even a graduate degree also increased a lot compared to 1990. All right, so in 1990, what is the bigger one? No high school graduate, okay? No high school graduate in 1990 is so significant, almost 25% in here, okay? All right, but after the associate degree in 2017 is increasing, and increasing even more for the bachelor degree and the graduate degree. All right, so those are the side-by-side bar graph that you can compare with, okay? You can make a general conclusion based on those graphs, all right? And then you can also do the graph horizontally, okay? So like I said, this is the way you can choose, you know, you can change this graph, right? You can change this graph type, you know, in here, right? So you can change the graph type as we did earlier. You can change it into the vertical, horizontal, that kind of thing. All right, so you can insert this one, and then you can, if you want to change it into this horizontal, that is okay. All right, so you can change it any one you want. You can even have a 3D graph. All right, you can even have a 3D, but you know, usually 3D is hard to do it for the graph. So 2D using the basic one still good, okay? All right, so those are the graph in here, okay? Also, same thing, construct a pie graph. We don't really ask you to do that by hand. Pie graph is a circle divided into a pie, you know, like a pie, like a pizza, right? You cut into different slices. So those are the pie graph, okay? Pie graph, you know, you usually, you can calculate how many degrees for each pi, right? But in the Excel, it will automatically do that for you. So we don't really ask you to manually calculate the number of the degree and then graph that manually, okay? So if you look at this one right here, which one is in 2017, which one is the highest pi? Looks like this one, high school diploma, got 27% is a higher, right? And then you have a bachelor degree, also pretty big. Some college, but not degree, also pretty big in here. So those are the pie graph, okay? And then you can insert a pie graph in here. Let me go ahead do a little bit pie graph for you. So I have this one right here. I can change this one into pie graph. Okay, let me just redo a little bit. I'm gonna just graph a little bit in here. Okay, so we're gonna insert this time, instead of the bar graph, we're gonna insert the pie graph. All right, so we have this. Okay, I'm gonna just enlarge this one. All right, so now we have this one called a pie graph in here, right? So this is your pie graph. All right, so and then you can even put a title in here. This pie graph is a little bit different because we're using this is the body part instead of the education. All right, so you can see this blue one, back pen is the most one, the bigger pie, the biggest pie in here. All right. So that is the pie graph in here. Okay, so that is our 2.1 already. Okay, constructing a pie graph in here. All right, so I think I'm going to stop right here. Okay, 2.1, we finish this up to 2.1. That is enough for the week 1. All right, I also want to show you a little bit this homework in here. Okay, so the homework, you can come here to do the homework, and then you also want to do a little bit this remedial section. All right, remedial section, I put it until October the 1st, but you can do that anytime in here. So at the beginning, you might have a little bit more because for the remedial, because I want you to do a little bit more remedial at the beginning, because later on in the statistic, we're gonna have more and more calculation. All right. So the beginning of the statistic, we don't have a lot of calculations, so a little bit lighter. At the beginning, chapter 1, chapter 2, usually a little bit lighter. So you're gonna spend a little bit more time in this remedial in here. All right. Any questions? I'm not going to hold you for the entire, the next section, but I want you to go ahead using the rest of time to do your own homework. Okay, since we are not in classes, so you're gonna do that on your own. And let me know if you have any question. You can send me the regular email, or you can instant chat in here. Okay, let me show you. You can instant chat in the course. If you instant check in the course, I know who is in the course, so I don't really have to you don't really have to say which course. But if you send a regular email, you do need to include the course every time. Okay, so there's an instant message right here. All right, you can instant message it inside the course if you want to in here. Okay, and I do check that every day as well. All right, any questions? Any questions?
Yes. So we just do the homework that's the 1 point, I think it's 1.3, 1.4.
You can do up to 2.1 if you want to. So if you do a little bit more this week, you're gonna do a little bit less next week.
Okay.
All right. Yeah, and then starting the remedial, it is 2 sections. All right. Any other questions?
You said the videos are optional because of the lecture?
Yes. Yes.
Okay.
All right. Any other questions? If not, you have a great day. Okay, I will be still online, so you can instant message me or send me the email if you need to. All right. Okay, so I'm gonna dismiss the class at this point. So I will let you go back to the homework, and then you can send me any question you want. I will be still on the MS team for a little bit while. So if you have any question, you can also come back again. All right.
Thank you, Professor.
All right, you're welcome. I'll see you. I'm gonna stop the recording.